Now we want to solve both of these right triangles, and notice that these are going to be special right triangles. Recall that to solve a right triangle means to find all three of its sides and all three of its angles. Angles part should be pretty easy. If this is 30, then the other angle up here, the other acute angle, has to be 60. 30, 60, 90 right triangle. Where this side's x, hypotenuse is 2x, then the base down here is x square root 3. If the hypotenuse is 1, then the short leg has to be 1/2 or 0.5. And the base down here has to be 1/2 times the square root of 3. Usually though we write this as square root of 3 over 2. It just looks like one complete fraction. Okay, so now the triangle on the right. If this acute angle is 45, the other one is also 45. It's a 45, 45, 90 right triangle where this side's x, x, and the hypotenuse x root 2. If the hypotenuse is 1, then I have to divide that by the square root of 2 to get this side. Don't like the square root of 2 on the bottom, so I multiply by square root of 2 over square root of 2 to rationalize it. So this side is really square root of 2 over 2. And so is this one. Square root of 2, that's a 2 over 2. Okay, we did this because we're going to use these numbers just a little bit on what is called the unit circle. But first, let's review radians. Remember, radians are just another way to measure angles. Instead of degrees, we use radians. Where a radian comes from is you take the length of the radius, this whole thing, and you wrap it around the outside of the circle. If you connect that to the center of the circle, it creates an angle, this angle right there. The measure of that angle is called 1 radian. It's the angle that's formed by taking the radius and wrapping it around the circle. I know from 3 to 1 on a clock face, that's 60 degrees, and I can see that this is just a little bit less than 60 for 1 radian. Okay, if I continue this around the circle, here's 1 radian, here's 2 radians, this is 3 radians. Now this diameter marks a half a circle, a semicircle, which we know to be 180 degrees. And I have this little part that's left over. This is 3, and this little part that's left over is 0.14159 blah 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 blah. So it takes pi radians to make 180 degrees, a semicircle. And that's the most important part for you to remember. It's the conversion factor, that pi radians equals 180 degrees. So 2 pi would equal 360 degrees. Look at that double box action. So let's do some conversions here. So 30 degrees, we want to turn it into radians. Easiest way to do this is with the train track method. Open up our train tracks. We want the degrees to disappear, so I want 180 degrees on the bottom, which leaves the pi up top. Now I simplify the fraction. The zeros can cancel out. 3 over 18 is 1/6. So this is pi over 6. Pi over 6. Do the same thing with 45 degrees. Pi over 180. I want the 180 on bottom again because I want the degrees to cancel. When I simplify this fraction, I get pi over 4. 45 degrees is pi over 4. 60 degrees, 180 on the bottom, so the degrees cancel, pi up top. Simplify this fraction, 6 over 18 is pi over 3. Pi over 3. Now we don't really have to do the train tracks on 90 because if 180 is pi, 90 degrees must be half of that.